On a modern map, the Indian subcontinent appears permanently bolted to the Asian mainland. This entire landmass is a geological emigrant. It originated in the southern hemisphere, on the complete opposite side of the planet. The proof is in the rocks. The deep geological layers of eastern India are identical to rock formations found in Western Australia, sharing the same age, minerals, and magnetic signatures. To understand how these regions were separated, we have to rewind the clock 200 million years. We are going to track the 9,000-kilometer drift that built the India we see today. The mountains, rivers, and plateaus of the subcontinent are the physical remnants of this massive geographical migration. 180 million years ago, India was locked inside a supercontinent called Gondwana, a single massive landmass that included modern-day South America, Africa, Australia, and Antarctica. The name Gondwana is taken from the Gond tribe of central India. When 19th-century geologists discovered that these ancient rocks stretched across multiple continents, they named the supercontinent after the people living on its oldest formations. The breakup began deep underground. A rising ocean of molten magma pushed against the Earth's crust, creating immense pressure. The crust eventually snapped. Gondwana fractured, sending India, Madagascar, Australia, and Antarctica drifting toward the north. This rupture isolated India, leaving it to cross the ocean as a solitary landmass. 150 million years ago, a new surge of volcanic activity forced Madagascar to split away from the Indian plate. The lava from this split cooled and stacked over millions of years, forming the massive mountain wall we now know as the Western Ghats. This volcanic formation physically tilted the entire Indian plate, creating a rising western edge sloping downward toward the east. This tilt dictates water flow. Today, almost every major river in southern India is forced to flow west to east, emptying into the Bay of Bengal. 80 million years ago, Australia also broke away, leaving the Eastern Ghats behind as a geological sister range to the mountains of the Australian coast. The exact points where these landmasses snapped off created the mountain walls and the plate tilt that today control India's river systems and monsoon cycles. Now completely alone, the Indian plate accelerated. It traveled 15 to 25 centimeters per year, one of the fastest tectonic speeds ever recorded. Roughly 60 million years ago, the speeding continent drove directly over the Reunion hotspot, a massive volcanic vent in the Earth's crust. Millions of tons of lava poured onto the surface, destroying the native dinosaur populations and creating the Deccan Traps, a vast hardened volcanic plateau that covers much of modern-day central India. Modern central India is built on the remains of this ancient lava field, a physical scar left by a high-speed volcanic encounter. 50 million years ago, the long journey finally ended. The speeding Indian plate slammed into the massive Asian plate. The kinetic energy of the impact was so great that it forced the crust to buckle and fold. The Earth was thrust thousands of feet upward into the atmosphere. This ongoing collision created the Himalayas, a 2,400-kilometer range containing the highest peaks on the planet. The Himalayas are the visible wreckage of this tectonic crash, and because India is still moving north, the mountains are still being pushed higher today. Because of their extreme height, the Himalayas act as a massive trap for atmospheric moisture and ice. The melting ice from high-altitude glaciers feeds the great river systems like the Ganges, providing the water that sustains over 500 million people. From the Western Ghats, the volcanic soils of the Deccan, and the rivers of the Himalayas, every major feature of the Indian landscape is a direct result of this journey. India is a living record of a 200 million year voyage, written into the very rocks and rivers of the subcontinent.